Assalamualaikum warahmatullahi taala wabarakatuh and a very good day to all. So this is the video presentation for group 1 for the BNR 37602 Technology Design Project. Our project title is the Automatic Vehicle Type Identifier using IR sensor. So our group consists of 5 people, which are Muhammad Aziz Fahmi bin Azadi, Nur Asma binti Kharuzaman, Muhammad Syamil bin Suhaimi, and myself, Ahmad Iqmal Husaini bin Ahmad Tazmin, and also Mio Muhammad Koyum bin Mio Maya.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Asma binti Kharul Zaman. My metric number is DN220084. So here I will explain about our research background and our problem affecting. So first is introduction. In the artificial and technological world context, transportation system nowadays has been implemented with modern technologies to mitigate the occurrence of vehicular accidents and simultaneously facilitate the comprehensive acquisition of data for traffic regulation. For our project, we used to develop an automatic vehicle type identifier system using infrared, which is IR sensor, at toll station introduced to enhance the efficiency of data collection and improve traffic management. This system aims to automatically classify vehicles accurately, such as cars and trucks, so that both of these vehicles can be separated from using the same road. For problem statement, in recent cases, most accidents on the road are related to the truck and lorry drivers. They are likely due to their negligence, such as overload, speeding, and from another aspect, lorry and trucks have more blind spots than cars and motorcycles. Another problem that usually occur on highways nowadays are traffic congestion on highway during festive season. This problem occurs due to bad traffic management, as there are poor data collection at toll stations. Manual toll collection are often slow and use manpower to calculate vehicles on the highways. This will result in poor data collection capabilities that will lead to errors and also leads to traffic congestion and longer waiting times for users. For Project our aim for this project is to develop automatic vehicle type identifier system using infrared IR sensor at toll station to separate big vehicles such as truck and small vehicles such as cars, to reduce traffic congestions by collecting data and to avoid accidents that is caused by mixed type of vehicles at one highway. Next, for description, our project uses 2 infrared sensors that are placed at the pole at the entrance of toll booth to detect vehicles. The sensors are placed at different height at the pole to detect the type of vehicle such as car or trucks. Upon the arrival of the vehicle at the toll booth, the type of vehicle is determined by its height. Once the sensor detects that the vehicle passing is a car, the sensor will send signal to Arduino to process the sensor data. If the vehicle that is passing through is a truck, the sensor that is placed at the same height of truck will detect the type of the vehicle and send signal to Arduino to process the sensor data. So our objective is first to design a controlling identify vehicle type system using IR sensor and Arduino. Second is to develop the design system to identify vehicle type by its height. Third, to test the performance of the design system. For the project limitation, this project can only operate and the number of vehicles can only be recorded once it passes the toll station. This project is limited to detect and record types of vehicles such as cars and trucks. This project can only record wirelessly only at certain range of distance, so it cannot be applied on vehicles that exceed the limit distance. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syamil bin Suhaimi. My metric number is CN22071. For our literature review based on our project, and after doing research, there are 3 previous projects that are related to our project. On this slide, explain about gap analysis between previous projects. For the first project, which is automatic toll gate system. Among the features of the projects are operate the system using Raspberry Pi as software to authorize the vehicle entry-exit and operate the DC motor. Next, this project is primarily designed to operate at toll gate to enable more efficient toll collection. And it uses digital image processing and optical character recognition to capture image of vehicle for identification of verified registered plate number. For the second project, which is about license plate recognition system, it operates the system by using OpenCV software to detect and recognize license plate vehicle. And it uses OpenCV image processing function that are essential for pre-processing tasks in license plate recognition system to help enhance the quality of license plate image and prepare them for subsequent recognition steps. And lastly, it designed to operate on the road and parking lot to recognize vehicles that violate traffic law. For the third project, which about smart parking system using RR sensor. This system is using Wi-Fi module, and it also provides real-time information about parking space availability. This system is relatively simpler as it primarily involves occupancy detection and information display, and is a very useful solution for parking management.
Hello, Assalamualaikum. My name is Aziz Fahmi bin Azadi. Metric number CN220108. This is system flowchart we project. From the start, the sensor one can detect, and then servo motor can be on, and LCD display car. And then sensor 1 and sensor 2 detect, servo can be off, and LCD display no entry. Now, project flowchart. From the start, firstly, identify problem. Secondly, discuss with teammates. Thirdly, brainstorm about title with teammates. And then divide and edit proposal report. And then approved by Dr. Anija, yes or no. And then listing the component. And then buying the component. And then discuss about design circuit, and then build coding using Arduino software, and then design circuit using Proteus software, and then test the circuit, yes or no, and then discuss about hardware circuit, and then design and build using hardware component, and then insert coding into Arduino Uno, and then test the circuit, yes or no, and then discuss idea for develop the circuit or hardware part, and then the project is complete and ready to present, and lastly end. And then system block diagram. From the start, we waiting for car or lorry, and then infrared sensor detect car or lorry. After that, Arduino detect and follow the program, and then LCD show car or lorry. After that, motor run to open barrier. Lastly, end. 3D layout design. We using the software Sketcho. Firstly, we add Arduino Uno, servo motor, barrier, detection pole, IR sensor 1 and IR sensor 2. The circuit design. We using circuit IO. We find the circuit in the Google and the some research. Development. After design the circuit, we make the circuit to work properly using Arduino Uno, breadboard and another component. This is our pin configuration for our group. We add power supply in 5V the ground width at the GND. The LCD we put in the pin A4 and A5, RS sensor in pin 2 and 10, and lastly the servo motor in the pin 3. This is our hardware design. We using teleform to make the road and make the accessory to the house. The time to take to make the hardware design during 4 days.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Ahmad Iqmal Husaini bin Ahmad Tazmin. My matrix number is CN220042, and I will be explaining the result analysis for this project. For the result analysis part, it starts with the system in this project works by detecting the height of vehicles that passes through it. So there are two types of vehicles that can be detected using the system. The first type is type 1, which is a car. One IR sensor is placed 1.5 centimeter from the bottom of the detection pole, which is the same height as the car model we use. And the second type, type 2, are lorries. Another IR sensor is placed on top of the first IR sensor with a space of 44 centimeter above the bottom of the detection pole, which is the same height as the lorry model that we use. So this system only allows the first type, which is type 1 vehicles to pass through it, and it will not allow type 2 vehicles to pass through it. When the first IR sensor detects movement, the servo motor will lift up the barrier for the type 1 to pass through. And when the second IR sensor detects movement, which is the IR sensor for type 2 vehicles, it will not allow the servo motor to lift up the barrier for type 2 vehicles. At the start of the system, the Arduino Uno will initiate the LCD to display welcome. As seen in the first picture, the LCD displays welcome for the users that is going to pass through the toll station. And after 2 seconds, the Arduino Uno will initiate the LCD to display the number of cars in highway, which is equivalent to the number of times the first IR sensor detects movement. The result of this can be seen on the second picture. So for type 1 vehicle testing, type 1 vehicles are cars as mentioned before. So when a car passes through the toll station, it will pass through the detection pole first. So at the detection pole, the first eye sensor will detect movement as it is placed as the same height as the car passing through. So when the first IR sensor detects movement, it will initiate signals to the Arduino. This will result in the LCD to display car detected for 2 seconds as a sign that it detects the type 1 vehicle. This result can be seen in the first picture. And then the servo motor will move to lift the barrier. The servo motor will move from 0 degree to 90 degree to lift the barrier for the vehicle, which is type 1, and also a car to pass through. After that, the LCD will then start the count for the vehicles that passes through and display car in highway equals to the number of type 1 vehicles detected, which is also equals to the number of times the first IR sensor detects movement. And as a safety feature, as long as the type 1 vehicle stays and the first IR sensor detects movement, the servo motor will stay at the position 90 degree and will not move to 0 degree so that it will not hit the type 1 vehicle. It will only move when the first IR sensor does not detect movement, and then the servo motor will move the barrier from 90 degree to 0 degree. Next is the Type 2 vehicle testing. Type 2 vehicles are lorries, as mentioned before. So when a lorry passes through the toll station, it will first pass through the detection pole. So when it passes through the detection pole, uh, the first and second IR sensor will detect movement, as the second IR sensor is placed as the same height as the lorry, so it will detect movement and initiate signals to the Arduino. And also this will result in the LCD to display no entry for 2 seconds. This is a sign that the system detects type 2 vehicle. As mentioned before, this system only allows type 1 and not type 2 to pass through. This result in the servo motor will not move to lift up the barrier. After 2 seconds, the system will reset to the default settings, which is it will display welcome back, but the LCD will also keep on displaying the number of times the first eye sensor detects movement, which is the number of Type 1 vehicles detected.
Assalamualaikum. My name is Muhammad Koyum bin Maya. My number matric is N220. So I would like to present about the conclusion. So for our conclusion is the advent of technology has ushered in an era of smart solutions, and transportation is no exception. One such innovation is the automatic vehicle type identifier system utilizing infrared IR sensors. This system aims to enhance traffic management, improve safety, and optimize resource allocation by automatically identifying and cater- categorizing categorizing vehicles based on their type. So I would like to discuss the outcomes of the research conducted on this system and provide recommendation for future works. So firstly, accurate vehicle identification. Accurate vehicle identification, the research demonstrate the system's ability to accurately identify various vehicle types, including cars, trucks, motorcycles, and bicycles, using RR sensor. The sensor effectively captured the unique infrared signatures emitted by different type of vehicles, ensuring reliable identification. So next, real-time monitoring and data collection. The automatic vehicle type identifier system provide real-time monitoring of traffic, enabling the collection of valuable data. The data can be utilized for traffic analysis, congestion prediction, and infrastructure planning. The system's efficiency in collecting real-time data showcase its potential to contribute to smart city innovative initiative. Integration with traffic management. The research explored the seamless integration of the identified vehicle data with existing traffic management systems. This integration facilitate the dynamic traffic control, enabling authorities to implement adaptive signal timing and manage congestion more effectively. So next, I would like to present the recommendation for future works. So, for Internet of Things, which is IoT integration, incorporate IoT sensors and this device into vehicle identification system. This could involve real-time monitoring of vehicle locations, status, and conditions, contributing to improved traffic management, logistics, and overall transportation efficiency. And then recommendation for future works, advanced RFID or NFC technology. Develop and implement advanced near-field communication NFC technology for vehicle identification. These technologies can enable seamless and contactless identification, enhancing user convenience and reducing the need for physical cards or tags. So for the lastly, biometric authentication. Explore the use of biometric identifiers such as fingerprint or facial recognition for secure and personalized vehicle identification. This could enhance the security of access to vehicles and relate system. And that's all from us for group 1 for presentation in our project. So thank you very much.